Hi everyone, thank you for coming to another video of Calculus 1. In this video, um, we're going to discuss about basic limit laws. I think you might remember that we talked about two basic laws. One is limit x goes to c for a constant function equal to k, and then limit x goes to c x equal to c. And we're going to learn another one, two, five laws here, six laws here. Uh, and you have the first one is called sum law. If summation law or sum law, if limit x goes to c fx and limit x goes to c gx exist, limit x goes to c, uh, x goes to c f of x plus g of x equals limit x goes to c f of x plus limit x goes to c g of x. That's the first one. And the second one, called the constant multiple law, for any constant k, and limit x goes to c k fx exist, then limit goes to c k f of x, k times f of x equal to k times limit x goes to c f of x. Now this is actually coming from this law, and you can use the next one that you learn to get that. The product law. Product law lim x goes to c fx times gx exist, and lim x goes to c f of x g of x equals limit x goes to c f of x times limit x goes to c g of x. And number 4, quotient law. If limit x goes to c g of x not equal to 0, then limit x go to c f of x g of x exist, and that should be equal to limit x goes to c, f of x over g of x is equal to limit x goes to c, f of x over limit x goes to c, g of x. And number 5, I'm going over this pretty quickly because it's available in the book, and you can take down or pause the video and write down your notes if you want. Power and Root's law. If n is positive integer, then limit x goes to c, f of x to the power n should be equal to lim x goes to c, f of x power n, and the root limit c nth root of f of x is equal to nth root of limit c f of x. And here f of x greater than or equal to 0 assumption. When n is even. If n is odd, it doesn't matter. And then if p and q are integer with q not equal to 0, then limit x goes to c, f of x p over q exists, and limit x goes to c, f of x p over q is equal to limit x goes to c, f of x p over q. We assume that limit x goes to c, f of x greater than 0, greater than or equal to if q is even, and if and lim x c f of x is not equal to 0 if p over q less than 0, because it's going to be a quotient function in that case. Okay, so these are the basic laws. It's there available in your textbook, as well as in this video. You can pause and see the videos whenever you want. And but most of the understanding comes from the examples. So let's do some examples. So first one, limit x goes to 2, x to the power 3. So this is just fx function, so I can use the laws of substitution, laws directly. So it's going to be 2 to the power cube, and it's 8. And example number 2, you have limit x goes to Um, Here, I just need to explain this a little bit here. So we have limit x goes to 2, x times x times x. Now we can put the product rule. Limit x goes to 2, x times limit x goes to 2, x times limit x goes to 2, x. And this is 2 times 2 times 2, right? This is the law. Limit x goes to c, x equal to c. So remember that. This is what we used here. So this is 2 cubed, which is 8. Let's see the next one. Number 2. Limit x goes to 2, x cubed plus 5 times x plus 7 equals limit. Now I can put the summation law. X goes to 2, x cubed plus limit x goes to 2, 5 times x plus limit x goes to 2, 7. This is summation law. And then I can put the product one here, like I did here. So this is from the previous example. I can put that as 8 without any problem, right? This is, I'm going to write it in this line. You know how to get that one now. And then they have a constant multiple rule. And then this is a constant. This is constant. So this is 8 plus 5 times 2 plus 7. 10, 15, 25. 25. And then number 3, uh, limit x goes to 2, square root x cube plus 5x plus 7. And I can put the root law. Now from the previous example, so this is actually root law. From the previous example, this content is equal to 25. So its square root of 25 is 5. Okay. And then we gonna get example number 4. We have limit t goes to -1, t plus 6 divided by t to the power 4. We can put the quotient rule. And you can put limit 2 times t to the power 4, and then this is called, and you could put limit sum law product constant multiple row, and then you can put the product rule 4 times here. Okay, this is constant, and this is -1 plus 6 divided by 2 times uh, -1 to the power 4. This is 2, will be 5 over 2. 5 over 2. um, and then we have another example. Limit t goes to 3, t to the power to 1/4 plus 5, 1 over 3. So we can use product rule. One third. Uh, so here we can write the product rule for, we can write negative in this case we have a negative value here, and you can write it as a quotient, or we can just put yeah, we will write the step by step. So we have limit 1 over fourth root of t to 3, and we have limit like that, plus 5, and the square root of 3, and we can write limit t goes to 3, 1 divided by fourth root of limit t goes to t 3 t times the limit t goes to 3 t plus limit t goes to 3 5. So this is 1, this is fourth root of 3 times 3 times, sorry, times cubic root of 3 plus 5. 3 plus 5. Uh, so this is 8 cubic root of 8, the numerator, and then fourth root of 3, and this is 2. Right, so that's the answer. That's the answer. Okay, so one other thing that I wanted to show you is sometimes that you cannot use product rule. For example, if you have f of x equals x and g of x equal x minus 1, uh, fx times gx is equal to 1. And if we find limit x goes to 0, f of x g of x is equal to limit of x goes to 0, 1, that's equal to 1. But if I use the product rule, what would happen? So if I use limit x goes to 0, f of x g of x, I can use the product rule, limit x goes to 0, f of x times limit x goes to 0, g of x. Now this is limit x goes to 0, x plus limit x goes to 0, 1 over x. This does not exist because this goes to infinity. Does not exist. Does not exist. So the product rule cannot be used. So the limit of the product, this is called limit of the product, exists. But the product of the limit does not. Does not exist. Okay, so that's a special situation here. That's a special situation. Okay, so I think that's the end of this lesson, and we talked about some rules or the laws, basic laws of limits, and we worked out some problems, and I will assign some problem for homework. And if you have any questions, concerns, please let me know. Thank you very much for listening.